Works already. We're going to continue with earlier on this morning where we were working on the area of ACD. So I gave you a clue. The clue is that we want, since the two triangles, the triangles involved are not similar, we try and find common perpendicular height. Because once we find a common perpendicular height, ratio of area is simply ratio of base. Okay, so over here, let me just erase all the irrelevant parts first. I'm going to compare definitely the triangle at the bottom. And there are three different perpendicular heights that I can create from that triangle at the bottom. So first, the most obvious one will be this particular perpendicular height. From C all the way, drop a perpendicular line down to AD. So that is one. This perpendicular height is not common with any other perpendicular heights you see in the other two triangles. Let me just remove it so that we don't clutter our screen. The next one I'm going to try will be, give me some time getting used to this over here. Now I'm going to choose this highlighted part as the base. If that is the base, the perpendicular height has to start from A, and then you rotate your bow such that your base CD is horizontal. We drop a perpendicular line down to that base, and it will look like this, where we extend our DC. So the base DC extended is that dotted line that stretches to the top left hand corner. And then we drop our perpendicular from A to the extended, which lies on BC. Now that over there is our perpendicular height if I choose CD as the base. Now it is very clear that this perpendicular height is actually common with another perpendicular height found in a smaller triangle, isn't it? This perpendicular height is the same perpendicular height for the smaller triangle if I select BC as its base. Okay, now I remember the issues with using my laptop. Okay, over here, if this is the base, you see the blue color dotted line? That is the perpendicular height for that smaller triangle. And then if the yellow color is the base for the other triangle, that same blue dotted line is also the perpendicular height. They share the same perpendicular height. So the ratio of the areas is simply from the small to the big, 6 to 9. Which is 2 to 3. Half times base times height divided by half times base times height. The half and the half cancel off. The height and the height cancel off. So it's just base to base. So in order to find area of ACD, our presentation would look like this. So area triangle ACD divided by area, so ACD is the big one, for the smaller triangle ABC. The ratio will be 9 over 6. You can do the half times base times height and slowly go and cancel and convince yourself all the time. But save time 9 to 6. It's just the ratio of base because heights are the same. So from here, we substitute in whatever other information we know. So area, triangle ACD, that is what I want, divided by area of ABC. Hey, look, I already wrote down it is 24 square centimeters. Divided by 24, this gives me 3 over 2. So our area of triangle ACD must be 3 over 2 times 24. 3 over 2 times 24, and we get 36 square centimeters. Okay, over here. So I gave you a piece of homework, so same thing. How about we try now? We try now, and then I give you the rest of the homework. Do you try the rest of the homework today? You have less homework. Good? Okay, let's do it now. Try it 16. Okay, let's start with our finding the area of triangle ABE first. Always try and find whether there are similar triangles. If don't have, right, so try it 16. We've got a trapezium, diagonals intersecting, with sides given, area of CDE 13.5. CDE This is our 13.5 square centimeters. They want us to find area of ABE. So I will indicate where my ABE is. Okay, so over here, ABE. I want to find that. I recognize that, hey, this shape over here shows me there are two similar triangles, top and bottom. Since I want to find the area of ABE, I put it on the top left-hand corner. Make life easier for myself. You will see that this is going to be a one-step answer. So area, triangle ABE, over area, triangle, the other one on top, ABE, CDE. Okay, now we need a ratio of the sides. We're going to square the ratio of the sides. So using the bigger triangle at the bottom, my corresponding sides will be our 10 versus 6. So 10 over 6. Put in other information that we know, meaning our area of CDE, which is 13.5. So area, triangle ABE, over 13.5 gives us 25 over 9. Therefore, area, triangle ABE must be equal to 25 over 9 times 13.5. We get 37.5. So that's part A. Now for part B, we want area of BCE. So just identify BCE over here, okay. To find this area, identify, got similar triangle or not? Then you try 3 different ways of proving triangles are similar. None of them will work because I don't have a similar triangle to this. Then I must check whether they have common perpendicular heights for 2 triangles. After you try drawing out all the perpendicular heights, you will realize that if I set CE as the base, then my perpendicular height starts from B. I drop a perpendicular line down. It should look something like this, where I extend the base CE, extend it out. So now I get this as my perpendicular height. Now you may have drawn it as BE as your perpendicular height because it kind of looks like 90 degrees. However, diagrams may not be drawn to scale. So I prefer to slightly adjust it to remind myself that, hey, no guarantee that BE is perpendicular to CA. Okay? Now, the base for that triangle on the right has 6 units with this total line as the perpendicular height. Turns out it is the same perpendicular height with this other triangle, with this as the base, or with the same perpendicular height. So earlier on, we found out that this triangle has area of 37.5 square cm. So putting the unknown in the top left-hand corner, part B, area, triangle BCE. I want to compare this with the other area of what we found in part A, triangle ABE. This has to be the ratio of the bases, since the perpendicular heights are the same. And the ratio of the bases will be 6 over 10. Carry on, substituting information that we already know. So area, triangle BCE divided by what we know, which is 37.5. This gives us 3 over 5. So area of triangle BCE must be your 3 over 5 times 37.5. So we get 22.5 square centimeters. Okay, so just double check the answer at the back. I believe this is correct. If there are no careless mistakes. What is the logic to it? Very standard stuff. Find similar triangle, don't have. Find similar height, common height. So then we move on to homework question. Anybody needs more time for this? Raise hand, got clarifications? Look at the number of steps. This is what we expect. We don't expect very complicated stuff. Next one, exercise 3.3. Question 3. Okay, so this should be a little easier. Dimensions given. Area of ABD 60 square centimeters. ABD 60 square centimeters. So just put on a diagram. They want us to find ratio of ABC over ABD. ABC, the big triangle, divided by ABD, the small triangle. Obviously not similar. Got common perpendicular height. It's not very obvious, isn't it? Common perpendicular height, because the base is very nicely placed for you, BD as well as BC. Both of these two triangles, they share the same perpendicular height. Therefore, answer for part A, area triangle ABC over area triangle ABD is simply ratio of bases. ABC has 10 plus 15 as the base. ABD has 10 as the base. Do your substitution. So area triangle ABC. ABD we have it in the question. 25 over 10. So area sorry. We don't need all this substitution because they just want the ratio only. Area ABD. This will be 25 over 10 divided by 5 over 2. So part A done. Then part B. They want the area of ACD. ACD. So this one over here. Okay, part B. Again, obviously, same height lah, same perpendicular height. Put your unknown at the top left hand corner. Area, triangle ACD. Divided by the known area. Area ABD. So because they have the same perpendicular height, ratio of area is just the ratio of base. 15 over 10. Now do the substitution. You know what, we save one step. Equals to 15 over 10. I know I'm going to multiply by the other area already, 60. So I save some time writing. So 15 times 6. 15 times 6. 90. Ken? Jia Tong okay? Gary okay? Aslami okay? Okay, so question 4 done already. You only have 4 more questions for your homework. So now I'll do question 10 with you. If you have already done it, you want to double check presentation, just watch. If you haven't done it, also can just watch that. ABC, EDC straight lines. We've got parallel lines over there with length 15. So clearly over here we've got similar triangles again. Right? Two shapes that I wanted you to remember, looking like this, as well as this. Always come on. Oh, see, appear again. So similar triangles. Area of BCD 150. BCD 150. Just put it down 150. Put in the units so that you do not confuse yourself with lengths. area of ABDE, 144. Oh, okay, that's interesting, 144. This time, this is for that four-sided figure, the quadrilateral. It is not for any triangle. However, when they put it this way, we know the ratio of areas for the big triangle to small triangles already, right? Just add lah. Get the area of the big triangle. Now, they want us to find ratio of AB to BC. So, this to this. Wow, we don't have much information on length, but we can work on ratio of area. So, we start off with area triangle, the big triangle first, ACE, over area of the smaller triangle, BCD. Let's see what this will give us. So, big triangle, 144 plus 150, divided by small triangle, 150. Use your calculator, 144 plus 150 divided by 150. Turns out it is 49 over 25. Are these numbers special to you? 49 and 25? Do they ring a bell? Are you sensitive to these numbers? What are they? They are perfect squares, right? If you square root them, you are going to get very nice integers. Is it a coincidence over here? Probably not lah. Okay? Ratio of the area is 49 to 25. What does that tell you about the ratio of the sides? Big triangle to small triangle. How much? 7 to 5. Any side, big triangle to the corresponding small triangle, 7 to 5. Now you can choose to write, AE over BD is 7 to 5. You can choose to write EC to DC is 7 to 5. But are they useful? Is that what the question wants? Question wants the base. Don't waste time doing AE to BD or EC to DC. What we are interested in is AC to BC. Ratio of the side. It is square root 49 over 25. That gives us 7 over 5. So that long side from A to C, we allocate 7 units to it. From B to C, we allocate 5 units to it. So this one 5 units, then we allocated 7 units, right? Then how much should AB be? If total 7 units, BC 5 units, then AB how much? Must be 2 units, right? Take note, I did not write units because this is ratio. Don't confuse yourself thinking that is 2 cm and 5 cm. This is ratio. So based on this, we can now write down our answer for part A. AB to BC is 2 to 5. No other working required already. I think it's very clear. Right, 7 to 5, obviously must be 2 plus 5 is 7 lah. So that's part A. Then part B. Part B says to find the length of AE. Place your unknown in the top left hand corner. AE. Corresponding length will be BD. Surely there must be some way for you to find BD. In fact, it is given in the question. BD is 15 already. So this must be the ratio of any other pairs of sides. For the big triangle to the small triangle. Big triangle, we've got 7 units. Small triangle, we've got 5 units. Find out your value of AE. So I skip one step, 7 over 5. I multiply this by the length of BD, which is 15. So 3 times 7, I get 21 cm. Done. Okay, so part A and part B. Now you have 3 homework questions. Reasonable? You've seen how this can be done, as long as you follow the flow.